Hello, my name is Susan Poss. I'm a math instructor at Spartanburg Community College, and I wanted to talk with you a little bit today about solving proportions. A proportion is an equation, and this equation is a very particular type of equation because it has a single fraction on the left of the equals mark and a single fraction on the right of the equals mark. So these are two equal ratios. Okay, so here's an example of a proportion. You can see here's the equals in the center, and then here's a single fraction over here on the left and a single fraction over here on the right. That's what makes it a proportion. It fits that special definition. So you can look over here to the side and you can see that the first thing we've done is to determine the LCD. Let me do a previous step to tell you where that's coming from. You need to include a factor of 2 in your LCD. You need to include a factor of 3 in your LCD, and this X factor is occurring once in the first denominator, once in the second denominator, and you list it only once. So that's where that 6X is coming from. So since we're solving equations, the process is a little bit different from adding and subtracting. So you're going to see me put a bracket around the existing equation. Notice I've not done any work yet other than to copy down the first ratio, put it in a bracket, put down the equals mark, copy down the second row, put it in a bracket. And the reason I did that is the step that you want to proceed with is to take this LCD, think of it as sitting over the number 1, and use it as a multiplier in front of each of these ratios or each of these fractions. So if you correctly choose the LCD, then you should be able to do some canceling. So I'm looking here, I'm going to cancel out. See, the X's are going to go out. I see this 2 cancels into this 6. So it looks like on the left-hand side, I see 3 times 1 times parentheses x minus 5. Okay, over on the other side, when I do the cancellation, I see the x's are going to cancel out, and I see the 3 is going to cancel into the 6 and give me 2. So over there on the right hand side, I have 2 times 1 times 6. Or 12. Let me go back. This doesn't look very good here. Let's fix that. There, that looks better. So what we just did there is a process that's called clearing fractions. So you notice that I started out with an equation up here at the top that had fractions in it, and now by multiplying through by the LCD, I have eliminated the fractions, which makes this much easier for me to work with. So let's do a quick distribution here. Let's add 15 to both sides, and let's divide by 3. So we've got our answer. Now let's talk about checking this. So if this is a test, you'd want to check it. So I'm going to scroll down and show you the check. Remember, the answer we got is x equals 9. So you're going to see on this next screen that we've plugged in, everywhere there was an x, we've plugged in with a 9. And we're asking ourselves, are these two things going to be equal? So 9 minus 5 is 4, 2 times 9 is 18. We got 6 over 27 here. Is that equal? And when you reduce these down to lowest terms, you see that it is checking out. So yes, my solution is x equals 9. Now when you're working on these equations that have variables in the denominator, you've got to worry about those restrictions on the denominator. The restriction here is 0. X cannot be 0. As long as you get an answer here that's not 0, it's an acceptable answer. It's a legitimate answer. If I had gotten an answer of 0, I would have to toss it out because it would be one of my restricted numbers. But we'll talk about that as we get a little further along. I'll show you one like that. Okay, so here's another proportion, a single fraction on the left, equals mark, single fraction on the right. Everything is already factored in these denominators, so it looks like the LCD needs a factor of x, so I'll account for that. And it needs the factor that's a prime binomial, x minus 6. So if you were, and we're going to note here, let's note what x cannot be. So if you recall, what we did was we took denominators and set them equal to 0 to see what the restrictions would be on the variable. So this variable has two restrictions. It can't be 0 and it cannot be 6. So if I work all this problem and come down here and get a 0 or 6, I'm going to need to toss that number out. All right, so what did I do with that LCD? I took the left side, put it in a bracket. I took the right side, put it in a bracket, and then came in and cleared the fractions by multiplying both sides, or each of those fractions, by the LCD. And why did we do that? We did that because we wanted to see these cancellations occurring here, because we are clearing out the fraction form. Okay, so be careful. Here's a 3 and an x left up there, nothing down here but 1, so I don't write that denominator down. And then here's a 5 times an x minus 6. I'm going to go ahead and write that down and distribute so I don't make any mistakes. I try not to do too much in my head. So I'm going to subtract 5x from both sides, and I'm going to divide by negative 2 and get a solution of positive 15. I'm going to run back up here. Is that a problem? It's not a problem because it's neither of those restrictions, the 0 or the 6. So there's your second proportion problem. There's the check where you're substituting in the 15 for x, and you can see it works down, the arithmetic works out, and we get two equal quantities, so we know the solution is correct.